All right, welcome to your next lesson today, which is modeling the distributive property and factoring. We are going to be focusing on learning goal number 23, which says I will be able to factor expressions, which is basically undoing the distributive property. Okay, so let's go ahead and mark in learning goal number 23, and then you can put your date over on the left side. All right, using the page sorter, let me get down to our lesson today. We'll get rid of that and zoom in here. So modeling the distributive property and factoring. Let's go ahead and talk about some background foundational stuff. So area of a rectangle, we know area equals length times width. Okay, and so as we go through, we have our length and width, and so we have our 4 times 5 equaling 20 units squared, right? Okay, so typically you have 20 units and then squared. I'm not going to worry about writing the units squared right now just for the purpose of this, but let's have the understanding that we know we write units squared for area. Okay, so our next one, our length times our width, we have our m times 7, or we would just have m7. Okay. Next one, we have x times v, or just xv. Okay. Now we have a situation where we have a longer rectangle, but it's separated. Okay. So we know our length times width for this one is going to be 4 times x, or 4x. And then we'd have to add this other length times width. So now I know that this side length is 4 times a 3, so 3 times 4 is 12. Okay, and if I added the 4x plus the 12, I would get my total units squared. All right, so for our next one, we have length times width, which is our 10x, and then we can go ahead and add the area of the next shape. And we know that this side length is 10 because it's the same size as the other one. And so we have 10 times 2 is 20. And so you end up with a 10x plus 20 is our area. All right, now shifting down to change our mindset a little bit. Instead of those rectangles being separated, we're going to start to push them together. Okay, and so when we look at the top, okay, here, and if someone was asking me, well, what's the distance of this one plus this one? Obviously, we would just add those together. And so you have x plus 9 is your total length of the top. Okay, and so when we're looking at number 7 here, what we want to do is start to understand our area as a sum. Okay, and so we have our 5x, okay, because we have our 5 times x, and so we have 5x plus our length times our width. 5 times 7 is 35. So our area is a sum. We can write area equals 5x plus 35. Okay. Now, our area as a product, okay, is going to look a little different. So instead of us saying 5x plus 35, we can go ahead and represent this as a product instead. And so we're going to pull the 5 out and show that we're doing 5 times the x, because that was our first one. Okay. And the 7 is our other distance. So really we're doing 5 times the x plus the 7. And so if we put those into parentheses like that, we end up with 5 times the quantity of x plus 7. And if you look at your distributive property, you can see 5x is there, and 5 times 7 is the 35. So these are the same things. Okay, so we basically undid the distributive property to create that. So let's look at our next one here. So I have an a plus 8 is my length of the top. Okay, and so the area as a product, I know my length times width. I have a 4 times the a, and then I have the 4 times 8. So my 4 is on the outside. I'm multiplying by the a plus the 8. Because if we combine those, then I have a total length times an entire width. Okay, so length times width, so that's the same thing, 4 times whatever that entire distance is. Okay, as a sum, we have the distributive property. So we have our 4 times A plus the 4 times 8 is 32. Okay, so there's my area as a sum and my area as a product. Okay, all right. Now, this bottom one is not really a group challenge because we've already done this distributive property. So if you want to pause, do them real quick, and then check, you can. I'm just going to go ahead and do them quickly here. So 2 times a 3x is 6x, plus 2 times 4 is 8. Okay. All right, next one. Negative 5 times 2x is negative 10x, plus negative 5 times 3 is negative 15. Okay. If I want to write that a little prettier, I can write negative 10x minus 15. Okay, both are accurate. One's a little bit more common to see. All right, and then the 1/4 times the 16. So we're going to distribute the 1/4. Okay, I can quickly KFC that just to make it easier to look at. And so 1/4 of 16 is 4. Okay, you can also look at this. Remember, 1/4 times 16 over 1 is essentially 16 divided by 4. Okay, and that's where I get that. Plus the 1/4 of negative 24, or just 1/4 of 24. We know our answer is going to be negative. 1/4 of 24 is 6. And so we have a negative 6x. Okay. All right. Now, you can have that, or you can have the 4 minus 6x, or it is very common to have the variable with coefficient first. And so you have 6x plus 4. All those are accurate. All right, now moving down to number 12, what I want you to see here is some other examples, and then we'll get a little bit more complicated here. Okay, so your first one that we're going to look at is our 2 times the quantity of x plus 6. Okay, and so what I want you to see here is our 2 length times our width. We had 2x in here, and then 2 times 6 is 12. And so you can see our 2x plus 12 as the sum. Okay, or we can go ahead and factor out the 2 and show this as a product of 2 times that that distance on top. Okay, so essentially we have the length or the width being 2 times the x plus 6, that distance up here. Okay, and really this still is width times length, or length times width. Okay, all right, now number 13. So what we're looking at here is we have a 6x plus 48. And so when we're factoring, we're looking at what number can we divide both by, or what is the greatest common factor of both of those numbers, whether it's the coefficient or the constant, so that we can pull that out to the outside. So first of all, let's go ahead and write our sum. We know our sum is 6x plus the 48 for our area. And then let's go ahead and pull out. First thing I want to look at is the 6. Can I divide 6 from that number and that number? And I can. So I'm going to pull out the 6, and I end up with just an x here, and I end up with 8 there. So we have 6 times x plus 8. And then you can always double check your work, okay, and go ahead and distribute, and so you see 6x plus 48. So over here, same thing. I'm looking at my numbers, and I'm determining what is the greatest common factor that I can pull out of those. Always looking at this number and considering it first. So I can definitely pull out 10. So I have 10 times x plus, and then 30 divided by 10 is 3. So for my top distance, I have x plus 3. Okay. All right. Now my sum is just 10x plus 30. Okay. All right. Down here, let's go ahead and look at these without the model now. Okay. So we're factoring out. So we're looking at the two numbers, the coefficient and the constant, and looking at what we can pull out. I can pull out that 5, okay, or divide both numbers by 5. And so 5 times what is 5x? Just the 1x. Plus 5 times what is 35? And we have our 7. So double check your work. So 5x plus 35 is correct. Okay, and then you also, let's go ahead and look at number 16. I'm first seeing if I can factor out the 3 from both numbers. I can go ahead and KFC that too, if that helps. And so, but you don't really have to. I'll do it without it. So I'm going to factor out the 3. And so I have the x minus, and then I can just look at that as a positive number. So 21 divided by 3 is 7. Okay, so we have 3x minus 7, and there we go, double checking to make sure that that's accurate. I just like to look at it and verify that it would distribute back to the original, and it does. All right, so in all of these ones, we are able to factor out that coefficient number. It doesn't always work so easy like that. Sometimes you really do have to think about the greatest common factor of both. So let's look at some of those scenarios right now. So we have a 6x plus a 21. Okay, so in this space, I have my 6x plus the 21. That's my area. Okay, and then what I'm thinking about is what is the greatest common factor that I can pull out of those? And so 6 doesn't work because 21 isn't divisible by 6. So I have to start thinking, okay, well, what's the next factor of 6? And so that next factor of 6, I'm thinking, well, 1 and 6, 2 and 3, my next greatest common factor ends up being 3. So I'm actually going to pull 3 out, okay? And so 3 times what would get me the 6x? So 3 times 2x. And then 3 times what will get me the 21? That's 7, okay? And so we end up with 3 times 2x plus 7, okay? Because that's my distance from here to here, okay? All right, I should probably use a point if I'm going to do something like that. And then just to double check, I like to just show the distribution, and I get 3 times 2x is 6x plus 21, and that matches, so we're good, okay? All right, on to number 18. Go ahead and look at your numbers here, and we want to see what we can pull out. Notice that the smaller number is with the variable this time, so that's something different as well. Again, if you want to KFC that, you can. However you want to be thinking about it is up to you. Okay, so I have a 60 and a 5. I'm wondering, can I factor out a 5 from both? In this case, I actually can. Okay, so I'm going to factor out the 5. So I'm dividing 5 for both numbers. And so for number 18, we have 5 times 12. Okay, but here's the thing we have to think about here. 5 times 12 equals 60. It doesn't equal negative 60. So for this one, I'm actually going to factor out a negative 5. So that's what's a little bit tricky with this one. Okay, so negative 5 times 12 ends up being the 60. Okay, and then if I pull out the negative 5 or factor the negative 5, I just have a. Okay, and negative 5 times a positive a, okay, is a negative 5a. So that's where it might be nice to KFC that. You can see how that looks now, okay? So it's the same either way, but you do have to make sure, this is where it's really important when you go ahead and write your factored problem. that you make sure that it actually works. So watch what happens here with this. Oops, I need to write my just A. Yikes. Slow down. There we go. My 12. 12 plus A. So watch what happens now. When we distribute this, I do get my negative 60 plus negative 5A, and that was my original. So I know that what I did was accurate. I always recommend you double checking by distributing the final answer. All right, let's go ahead and look at these without the model now. So again, we're looking at the two numbers. This one's a negative 35, and we're seeing what we can factor out of both those numbers. So 10 does not work, so I'm thinking about other factors of 10. And so probably 5 is our next greatest common factor. So I'm going to pull out the 5. Okay, and so now I'm asking 5 times what gets me the negative 35. So this is 5 times a negative 7, okay, plus 5 times 2x will get me the 10x. Double check your work and just sort of think about that factoring. 5 times 7 is negative 35. 5 times 2 is 10x. So that works and is accurate. Okay. This would also be accurate if you wrote it like this. Okay. All right. Over here, number 20, we look at our two numbers and think about what we can factor out of there. 6 does work as a greatest common factor. So I'm going to go ahead and write my 6. Now, because both are negative, I can actually pull out the negative and just have positives inside. Okay, so I can KFC like that. Okay, we can look at it both ways a little bit here. So I have negative 6 times 6 equals a negative 36 plus negative 6 times x equals the negative 6x. Okay, so when I look at that, it does equal the same thing. And again, this is also appropriate. A lot of times you'll see people write the variables first and the constant last. Okay, so that's number 20. Okay, is that or that? Okay. Group challenge number 2. Go ahead and you can do these ones on your own and pause and then check your work and see how you did. Okay, so I'm just going to go ahead and do these real quick now. So the 6, we can go ahead and 6 cannot factor out of both those numbers. So 3 will not work. So it looks like we'll pull out 2. And we have 2 times 3x plus 4. Okay. Next one, I can't pull out a 10, but I can factor a 5 out of both of those. Okay, so we have 5 times 2x, and then minus 5 times 3, and so there we go. And so you could have KFC'd that or left it like that. You just want to double check. 5 times 2 is 10x, and 5 times a negative 3 is still a negative 15. And then your last one, I can pull out or factor out the 8 from both numbers. Okay, they're both negatives, so I'm going to factor out a negative 8. And we have 3 times 8 is 24. And then we have just our x here. Okay, so really think about what this turns into. So double check your work here. So I have a negative 8 times 3 is a negative 24, and then a negative 8, and an x is a negative 8x. So this does show to be the exact same thing. So double checking again to make sure you're good is really important. Okay, all right, that's it for that. Good job.